Today we're going to work on fractions. We're going to work on understanding what equivalent fractions are, and we're going to use that information in order to add fractions with both like denominators and unlike denominators. And we'll find out what I mean when I say denominators in just a second. A fraction shows a relationship between the parts of an object and the total of the object themselves. So a fraction is a ratio. The bottom number is often called the denominator. I'll write that here. Denominator. Let's try that again. I'm sure I can spell it better. Denominator. The denominator tells you the total number of parts of your object. The top part is the numerator. And the numerator can tell you lots of different things. It can tell you the number of parts, let's say, of this pie, this circle that I have. It can tell you the number of parts that are shaded. It can tell you the number of parts that are unshaded, missing, filled in, whatever, however you want to look at it. In this case, I have an object, let's say this is a pie, and it looks like I've cut my pie in half. Now, as I've cut my pie in half, how many pieces does it have? It has 2 pieces. So the value of the denominator in this illustration here is 2. I have 2 total pieces. So I may ask the question, well, how many of these pieces are shaded? How much of this pie is left, say, after having eaten some of it? Well, in this case, the green part is 1 of the 2 pieces, so I have 1/2. I'm representing 1/2 here. Now here's where things get a little bit interesting, and here's where we have to understand a little bit something about equivalence. Let's take a look at the value of the fraction that we just have drawn, that we've just have illustrated, and we've written down the value of it. Let's see what it means in terms of a number line. Now on this number line, if we start at 0 here, and we call the next one, let's just move over, this is 1, and we'll say this is 2, then I can say that each tick mark, each value, is equal to 1/2. So if we were to plot the point where this value is, this pi, we could say it is right here at 1/2. Now what we mean when we say equivalence is, what if I were to draw a line and make an even cut across my pie here? Do I still have the fraction 1/2? Obviously, yes. I haven't changed what I've shaded, but I have changed the number of pieces of my pie. See, before I had 2 pieces, now I have 1, 2, 3, 4 pieces. So this 1/2 is saying that, well, if my pie were cut into 4 pieces, then the number of them that are shaded is now 2. So equivalence means that another way of saying this point here, 1/2, would be to say 2/4. Those are the same value. What if I further cut my pie again? I bisected my points here, cut this way. Sorry, that's not the straightest of lines, but now I have 8 pieces, right? I have a total of 8 pieces. So how many of those are shaded now? What is equivalent to 1/2? If we have a denominator of 8 pieces, then our numerator has to be 4. So another way of saying 1/2 would be 2/4 or 4/8. All of these values are equivalent. in the same way that all of these fractions are just ways of cutting this half-cut pie into more pieces. Now let's see what that means in a slightly different context. Here we have a pie, again, that's now cut into how many pieces? Well, let's count them. There's 1 piece, 2 piece, and 3 pieces. So I know that the denominator, the value, is 3 pieces here. Now again, I want to ask how many of these pieces are shaded, and it looks like I have 1 and 2. 2 of them are shaded, so I have 2/3. So the fraction for this pie is 2/3, and please bear with me. I know it's a little elementary, but I want to make sure we understand equivalence here. Let's say I took each of those pieces then and cut them in half. Now I have a new fraction. The value of the fraction hasn't changed, but the number of pieces that I have cut, I now have 1, 2, 3, 4, 5, and 6. I have 6 pieces now. So the denominator, the value of the denominator is 6. And the number of pieces that are shaded are 1, 2, 3, and 4. So 4 of my 6 are shaded. That's the same as saying 2 out of 3 pieces are shaded. Those are equivalent fractions. So I can say, based on that information, that 2 out of 3 is the same as 4 out of 6. They occupy the same space on my number line. Now here's where it gets really interesting again. Notice that 4 is simply 2 times the number 2. And that 6 is simply the number 3 times the number 2. Now any number over itself is a factor of 1. So what information this is telling me is that if I multiply any fraction by 1, or any number over itself, I don't change the value of the fraction. I only change the number of pieces that our pie is and how many of the pie is cut into. Let's take another look at that just to see one more example. Now here's one that you've kind of already seen. You've kind of already seen it because this pie is cut into 4 pieces, and we've seen in the past where the pie was cut into 2 pieces, and we had 1/2 of the pie shaded. Now how many pieces do we have of this pie? Well, there are 1, 2, 3, 4 pieces of the pie. How many of those pieces are shaded? Just this guy right here, just the one. So this is the fraction 1/4. And again, I can cut through this pie a couple more times to change not the value of the fraction, but to make an equivalent fraction. So if I cut this way, let's do this a little more cleanly, and then I cut this way again. Keep going. There. Now, how many pieces is my pie? Well, it's 1, 2, 3, 4, 5, 6, 7, 8, and of those pieces, 2 of them are shaded. So that now I can say that when my pie has 8 pieces, 2 of them are shaded. That's the same as saying that 1 of the 4 pieces are shaded. Can we cut it again? Sure, let's just go ahead and try that real quick. Sorry if I don't get exactly through the middle. I am not a professional artist, so we'll bisect that one, we'll bisect this one again. Get that right up to the middle there. Okay, we'll bisect this way as close as possible. And we'll try this one again here. Now we've cut all of our 8 pieces in relatively half. So how many pieces do we now have? Well, if we cut our 8 pieces in half, then we should have 16 pieces. Let's see. Here's 1, 2, 3, 4, 5, 6, 7, 8, and then that's repeated again, and 8 and 8 is 16. So just for the sake of argument, let's just go ahead and write them all in. 11, 12, 13, sorry for my bad handwriting, 14, 15, and 16. So 16 pieces. And of those pieces, how many of them are shaded? Well, if when we had 4 pieces there were 1, when there were 8 pieces we had 2, then we must have 1, 2, 3, 4 of them shaded. So 1/4 is equal to 2/8 is equal to 4/16. That's equivalent fractions. In the next video, we're going to see how to add fractions, and we'll get to use our little equivalence idea a couple of times.